Well, hi, good morning. Thank you for joining me in my shop here. It's the last day of July, and I didn't post a video yesterday, but I was in here working for a good hour, just trying to do some alignment work. And at the end of that hour, I just kind of threw my hands up and said, well, enough of that. So what was happening yesterday was confusion around the instructions, and I'll show you where the confusion comes from. I think I sorted it out after an hour of fiddling around. So we're going to start by looking at the instructions and trying to plan out how to approach aligning the shortwave bands on this radio. Okay, so this is the sheet of information about the radio. I've read through this. This is all regular kind of stuff when you're doing alignment work. And here's where the problem is. Let me zoom in on this here. All we have to go on is this chart, if I can call this a chart, or this diagram. So I've done steps step one here, step 2 here, and now I'm on step 3. So if we go and look at step 3, you see it says broadcast. I've done step 3. Well, off to a dangerous start here. I've done step 4 and step 4. 2 step 4s. I'm on step, and 3 step 4s. So I'm on step 5. Step 5. Here we are. 31 meter band and C band. Okay, so that already causes me to stop and go, what? You have one adjustment for 2 bands? How can this be? Core L17 and L18. Two cores, but it's only pointing at one thing. What's going on here? This is what threw me off for really about an hour before I felt comfortable in interpreting this. So let's go look at the schematic for a second, and we'll find this L17 and L18. Okay. L17 and L18. Let me zoom in a little more. L17, 31 meter and shortwave C-band oscillator. There's this is an unusual coil. You see how this one's just a coil of wire, and there's a thing at the, piece at the top and a piece at the bottom. This one's got a tap halfway through it. It's got a wire coming out halfway through the winding, or 3/4 of the way through. That's a little different. This is indicating that there's one slug adjustment inside this coil, and making that adjustment affects both the 31 meter band and the C band. How does that work? How do you align 2 at the same time? So then I began wondering, well, is there more to do? This is the part I kind of missed yesterday. Is there another step? Maybe first you adjust this based on the 31 meter band, and then you counter adjust something to bring the C band to where it should be. And although this is showing the C band as part of this arrangement, you're really not intent on aligning the C band using the slug in this coil. True or not? I don't know. So let's look back at the instructions again. So if we find instruction number 6, what comes after this? Here's number 6. Shortwave C band oscillator trimmer at 17 kilocycles, 17 megacycles. 17 megacycles is the top of that band. The 9.5 is the middle. So is there another thing yet to adjust? I performed all this yesterday at the end of the day, and it did not work out very well. So that's when I just quit in frustration, frankly. Is there another thing? So where's 7? Here's 7 up here, 25 meter band. There's another 7 here, 25 meter band. And that's it. Wait a minute. What number is that? That must be 8. That must be an 8. Another 7. On the 25 meter. 25 meter band has 3 adjustments. Well, this is just kind of crazy. But the C band has only 1 adjustment, this one. Okay, so what we're going to do is we're going to, based on the 31 meter band, we're going to align the radio at 9.5 megacycles. And then we're going to go on and do the C band by using this trimmer. And it's not going to work out, but I'm going to try that. Now you might say, how do I know it's not going to work out? Because it didn't work out yesterday. Okay, let's get the radio on. So 9.5, this is the 31 meter band here. 9.5 is where the pointer is. On the C band, 9.5 is down here. Well, it's a different position in the tuning capacitor. I have no idea. I have no idea. Let's leave it at that. Okay, we're going to give the radio a few minutes to warm up. You can hear it's actually, the signal generator's at 9.510, and you can hear it coming out of the radio here. Is that what that is? Very low power. It's low power. Okay, we're going to let this warm up for a little bit though before I start. Time for some coffee. Okay, I think I'm ready here. Let's just check the tuning here. Now I did do this alignment yesterday, so this could be pretty close. Let's see. Radio's tuned to 9.5. Very close. Okay, take a look at the AVC voltage here. It's really right on the edge there, just to let you see what I'm doing. I'm adjusting that. Yeah, I'm just grabbing this with my hand. Very sensitive just to the, even just a little. But that's the peak there. Let's check. There it is, 9.5. Okay, so I've done what it says, I think. Now the next thing is we'll look at where 9.5 is occurring on the C band. Now also the C band is very weak, so this is another aspect of this thing. So we'll set the volume like that, switch down to the C band, and it's just gone silent. Now we'll tune to 9.5 here without changing anything else. You don't hear a thing. Turn up the volume way up. Very weak, isn't it? Okay, so I'm going to turn up the signal. The signal on the signal generator to do that last band was producing a signal, not a very strong signal. The typical antenna type signal from a weaker station. We'll go. That's a stronger station, if you like. Something that any radio should be able to pick up without any difficulty. What do we get here? So 9.5 down here. There it is. It's not located at 9.5. It's not far off. It's not as bad as I thought, actually. Getting this band to be accurate and precise is not very important. It's really these three here, these spread bands, that are really important to get tuned correctly. So now there is an adjustment for this band alone. You're supposed to do it at 15. I'm going to do it right here. And let's see if I can get away with this. Let's see what happens. This is the adjustment here. You know what I'm gonna do? I'm gonna go back to the other band. Don't need all the volume. Put this right on 9.5. See, the strange thing about this other adjustment is it's a capacitor right on one of the tuning capacitors, and it's a trimmer capacitor. I think it should affect every band. So what are we doing adjusting this late in the game like this? So I don't quite understand it. But here we go. So this is really meant to adjust a different band. I'm going to check to see if this adjustment affects the 31 meter band here. Here we go. I would say no. It makes no difference. Okay. Put it down in that typical spot. We'll go back now. And we'll tune this to 9.5. Turn up the volume. It's still weak. Now, obviously, it's not coming back on an alignment. Okay. So we want it to point at 9.5 here. So the adjustment is. Turn this in the direction we want to go. Try to find it again. My experience yesterday was you can't adjust this very far. This is better. Is the sensitivity of this band is coming up. Just listen to the hiss here. Give me a hiss. Okay, a whole hour down the drain yesterday, but this is working properly today. Good thing I stopped yesterday. Can we get it any closer? It's 9.5 exact there. Wow. Okay, let's do the noise comparison here. I'll tune off a little bit. Still no comparison. This band is still not very sensitive, but is working. This is 9.33, this station. This is among the very strongest shortwave stations. Almost always present during the day here. This is coming from the United States, maybe 1,000 miles away or so. So one of the challenges in using this band is that you can't turn this control very much before it just goes right through. You could miss it. But these bands, you can it's much easier to tune. Unfortunately, this station is 45435. You might be able to get it. Let's try. Maybe now that things are aligned. No. That's 9.45, 9.4, 9.35, 9.3. I think we should be able to get it. That's definitely 9.5 there. Well, is this 9.65? I'm going down the rabbit hole here. This is. Well, 9.65 is there. what is this? Should be 9.4 here. So that station I'm trying to get is probably just off the scale, and it shouldn't be. So it's almost as if this is more spread than it's really intended to be. This is really 9.5 here, right? I should probably complete the entire alignment process before checking this stuff out, because sometimes each band is being influenced along the way. I don't think that's really the case here. 9.5. Sure. So what we've got is a radio that's accurate here, but is spread out more than it should be, going this way. Can't do anything about that offhand. So we're going to move on to the next band. We're going to complete the alignment. 25 meter band. Let me just peek at the instructions here. In this case, the 25 meter band has 1, 2, 3 adjustments. There's an oscillator at 11.8. Has a antenna trimmer, and has an RF trimmer. So there's only one oscillator, and that's the third adjustment in. That's here. That's this guy here. Done at 11.8. Okay, that's roughly the middle of the band. That's what they're doing here. Okay, we'll feed them 11.8. Way off. Okay, so another issue with these radios is getting all radios, getting the local oscillator on the right side of the target frequency. So remember, when the local oscillator is 460 kilohertz away from the target frequency is converted to 460 and comes out the speaker. And so the local oscillator is floating a little above the pointer, so to speak, all the time. So as you tune the radio, the local oscillator is moving up, and the frequency that that's 460 kilocycles away is down here somewhere, like this, all the time, or whatever the arrangement is. But you can get the same effect if you just move the local oscillator onto the other side of the target frequency. You'll get the 460 difference down here. The only difference, and this is very difficult to pick up on a band like this, is one of these will be a little weaker than the other because of the other tuning aspects in the radio. But not much, because there's not much difference between 11.7 and 11.9 megahertz. I mean, that's the difference between this and this. Did you see the difference? No, it's so small between this. Hello, hello, what was that? Don't know, that's a little odd. Okay, getting focused on what we're doing now instead of yapping and talking. So so this thing's actually producing 11.2 here. That's way out. Let's see if I can get it. So it's very hard to get everything on camera here, so you can see the whole schmo. Now I'm going to walk right in front of this and block everything, aren't I? Yes, I am. So you're going to have to watch the meter. Maybe watch the meter and the radio. You can't even do that. Hey, spend all day getting these cameras in touch. Okay, the old tried and true. We'll do that. I'm going to step right in front of the camera now. Son of a gun. I can't figure it out. I cannot figure it out. Okay, we're going to forsake the indicating meter. Getting a little ride around my shop. Okay, so we want to bring this down to where we hear it, and then move it in the direction we want to go. up a little bit. And now I'm going to turn the adjustment back here. And hopefully I can find the tool to do it with. Cannot find it. Let's try this. Third one in. Find it. There it is. So now I know which way to turn this. Okay. And we're on the way up to 11.8. So I'm going to turn this a fair bit and go hunting. 11.4. 11.5. You're getting louder as I get there. Signal generator set to 11.8. Okay. Tune the radio in. Now we gotta watch the meter. Okay, checking the dial for right on 11.8. Everything's good. 11.8. And I think that brought up the sensitivity of this band. Okay, next band. Next band is the 19 meter band. It's probably done it where? Okay. Wait a minute, I got more adjustments to do. Jimbo, you're jumping ahead. Don't make a mistake. Back to 11.8. There's a bunch more adjustments. Okay, next adjustment would be the there is another oscillator adjustment. 25 meter RF. No, I'm sorry, I'm reading this wrong. 25 meter BS RF trimmer? BS? What's a BS? RF trimmer, that's what I want to see. C1. I see one. Okay, I need a blade. Okay, and this is done at 11.8. Hold on here, something has gone terribly wrong. Oscillator core, 25 meter. Is there something wrong? And is this chart wrong? 25 meter RF trimmer. Okay, no, that's fine. I'm just confused. See what's happening here? I'm losing my mind. Is this the right thing? Turn it a bit. Yes, it does affect the meter. You probably couldn't hear that. Change. Okay, watching the meter now. Looking for where the peak is. This guy just wants to be open all the way. Can't get a peak to show on the meter, but that's where we're at for now. Good. There's one more adjustment, and that's a 25 meter antenna trimmer, and that one is way up here. Okay, turning it, and here we go. Okay, this one shows a nice peak. Great. There. Okay, check it just to see what this sounds like now. That was not much volume. Not bad. Very good. I think that's good. Okay, now we're ready to go to the next band. Next band, we're now on step number 8. 19 meter band, oscillator. Okay, and then there's probably another step in there somewhere. But we'll do the oscillator first. The oscillator is done at 15 to 60. 15 to 60. Really? 15 to 60. Not 50? 60? Why? Why would they do that? I'm so suspicious of absolutely everything that's in these instructions. Oscillator core L15 at 15 to 60. Okay, why not? 15 to 60. Okay, we'll go up there. Volume's up a bit. 15 to 60. I don't hear a thing. More power. Oh, it's way off. It's way off. It's way down at 14.9 when it should be at 15 to 60. Way up here. Oh, there's another one. Uh-oh. Uh-oh. Let's try moving this louder one. Okay, first of all, which way to turn the control? Okay. You're getting louder, the noise coming. I think I'm going to guess what happened here is the same individual who is fooled with this a bit, this radio. Okay, and then we got eyes back on the meter. The guy who fiddled around with this before fiddled around with these adjustments, you know, because they're up. You get your hand on them easily. They practically scream, "Adjust me, see if I help." But if you don't follow the instructions and use test equipment and just wing it, and if you have little to no experience, it's only gonna go downhill for you. If you try to do this alignment stuff and you don't have the instruments to do it, no. That's what I would say. Like, my experience with the instruments is problematic. Okay, so we've been through the alignment once. I know from experience you have to do it a number of times in its entirety quite often. Now you see all these adjustments have been raised. Even this tall one got raised a bit. This one, not so much. Well, I think it's time to stop for a minute and put on an antenna. We're going to listen to this radio on all bands and see what happens. Okay, now we're going to try to assess this radio as best we can here, comparing it to the reception on the SDR radio. You know, the shortwave varies day to day, hour to hour, so you never really know what you got going. So I'm going to use the SDR as sort of a standard way of knowing what's going on a band. Now, if we look at the SDR here, this is the 15 or the 19 meter band, 15 megahertz band here to here. This blue bar, a little hard to see, and you see one whopping signal right here. Now that's almost certainly the local oscillator coming from the radio beside me. Are there any stations here? So we're going to listen to the SDR, and I'm going to check a few here. 15770 is nothing there right now. Let me just check. 157, nothing there. There's a strong signal off then at 15770. See, the problem here is if I tune this old radio across the band and hear nothing, what am I going to know? I'm going to think the radio's bad. so there's no station there. No station there. Okay, this big thing is a local oscillator. I'll just tune the radio a little bit and you'll see it move around. See those other signals? Moving around? Yeah. I gotta comment on those. These things out here. Okay, so there's nothing. By the way, I have the SDR radio connected to exactly the same antenna as the tube radio. There's nothing. There's nothing to hear. There's just nothing there. Maybe there's something down here at 140. I think this is probably, no, let's see. So there is a station there, but it's very hard to hear. 15165. It's 15165 is in this area. It's so weak. Let's see if we can hear it on this radio. I'm going to turn the sound off to the other one. So all we're hearing is that big speaker there. 15165. Right around in here. That's probably it. Not much different than the SDR in terms of reception quality. You couldn't really listen to this. It's too weak. Listen very carefully and see if we can hear something else. Oh, what's that? What? What's that? It's my cat. Hey, Peanut. What are you doing? He's saying out. He wants to go out. Okay, I'm going to stop for a moment and make my cat happy before I continue on. Hello. Okay, he's outside and he's happy now. Back to this. Notice I don't have the volume turned up too high. That's good. Just the one signal here, but you know, same as the SDR. Okay, next band down. Let's compare the noise level. Very low there. You probably can't hear it. Up a little higher. Suggests the band's a little more sensitive. Let's go to, I'll turn this down. This is from 11.7 to 11.9. We'll show you what the band looks like on my SDR software here. So once again, right away you see a whopping signal, this thing here. This is the local oscillator coming out of the old radio. So you know if the radio is tuned to 460 above this. Let's just double check a few things here. Okay, so if this is 12, about 460 below this. So we've got to subtract 460 from 275. Someone help me. I don't know. Oh, I just look on the dial. The answer is right there, 11,700. There's something right here. What's this? It doesn't look like a radio station. Let's listen. No. Again, I don't think there's anything here to hear. Anything here to hear. It's a bad day. A bad day on shortwave bands. Wow, it's just nothing. What do you say we check something else? The I think it's called the SFU. Just see where that stands right now. Okay, so that's going to be, we could find it here under space weather. If you look over here, somewhere they report it. Speed. I thought they reported it. 152 SFU, that's really high. Yesterday this was like 95. So this should indicate shortwave should be good. That's my understanding of how this works. The bigger this number, that's a really high number. The better shortwave should be. Doesn't seem to be working that way, does it? It makes me wonder about my antenna. So maybe I'm just going to check my antenna situation out here before we go too much further. And I'm going to stop while I do that. Well, the fact is, there's really nothing to hear on shortwave right now. Let's go down to the 9 megahertz band, and we'll see what we can do down here. Let's try this radio first. So let me just shut the sound off. So sensitivity, good. Nobody home. You know, it's just before 10 o'clock in the morning. And there's nothing showing up. Let's take a look at the 9, at this band, 31 meter band on the SDR here. Okay, so that's got to be down around, oops, around 9. Here we are, it's over here. Wow. What is going on here and here? Let's listen to this one.
It is because of Easter. It is assumed that is when the Savior was resurrected. So
what is going on here?
Calendar, they effectively.
What is that? And what is going on over here? Where's the local oscillator? Why is it not? So let me tune the radio a bit. Oh my gosh, what's it doing way up there? Yeah, lots of things moving now, but I think the local oscillator is the one that's up around 10.5. So at 10.5 with a 460 IF, this radio's ready to receive 10.1. That's not right. This is way off. This is like a million miles off here. Or am I just crazy? Or is that the local oscillator down at 9? Local oscillator set to the wrong side. So the strongest signal is down here. This is probably the real local oscillator. This is a radio station here.
On his calendar. Whether that law strictly enforces.
If we can get this local oscillator to be 460 away from here, then we should hear it come out of the speaker of the other radio. We haven't heard this station. It's been out of range. In fact, look, it's not even in the standard shortwave broadcast range. This is coming from the United States, this station. Okay, something funny going on. So it looks like I've set the local oscillator below. Is that correct? Now, so 460. So if this is, so it'd have to get the local oscillator down in this range to get 460 kilohertz between them. So I'm going down there. Do we get there? Okay, that's the bottom of the band. Bottom of the band. This frequency is basically almost 9. Let's use 9 for easy figuring. 9 plus, whoops, I didn't mean to do that. 9 plus 460. What happened there? 9 plus 460. 360. That's enough. We should be able to hear this. I gotta do the math more accurately here. too stupid to add numbers these days. Okay, so the local oscillator is sitting at 8960. Grabbing my somewhat unreliable calculator here. We're going to calculate. We're going to take the frequency 8960, 8960, and we're going to add to it 460 plus 460, 9420. Yeah, so right now the radio is actually tuned to 9420. We're not getting anywhere near the 93 where the station is, so that's why we're never going to hear it on this radio. It's here. We can't get to it. And there's nothing else on here. This is just disappointing. Okay, let's go back up to the top band, because I really can't compare the radios functioning when they don't have any signals to tune to. That's the one we got before. Well, I don't get it. The SFU was at 150. Everybody should be manning their shortwave radios today. But this is dead as a doornail here. So I guess maybe the SFU isn't the whole story. The atmosphere is very complicated. I guess that's the way to end it. Well, we can't really do a good comparison. Don't want to go through the signal generator test just yet, because I think we're on our way for another pass through the whole alignment process. One thing we will do, we will quickly check the sensitivity based on noise. And I'm going to take the antenna off and everything off. Okay. So that band goes quiet. Hoo-ah, and this one's really hopping. This guy's still in trouble. It's just nothing. But this guy will pick up the 9.3. Yeah, we gotta put the antenna back on. Put the antenna back on, Jim. Get the 9.3 and then call it a day. Okay, antenna on. Radio comes to life down here. The radio's active just in the area where I did the alignment.
Jill, and it's conjoined things showing paralyzer. Romans 8. There is therefore now no condemnation to them which are in the anointed.
This is a whoppingly strong signal.
The Savior himself in John 8 declares, neither do I.
And it's coming in with noise.
If you've been struggling under feelings of guilt or shame, shrug it off, reject it.
They take the ground off the antenna. Sometimes it doesn't help. Ooh. How about I hook up the antenna? I didn't have the antenna. I hooked up the wrong thing here. Duh. Are you kidding me? This is working better with no antenna? At all? The antenna amounts to the black wire hanging out the back of the radio there. No way. Really? Really? No, there's no way it can work better without an antenna. That's a crazy idea. It's loony bin. Loony bin. So what was what's happening down there. Ooh, what was all that? I think that's a volume control. Radio, what are you doing? What are you up to? Behaves so weird. I got this thing tuned up a little hot in this area. But I think if we put the antenna on, it'll stop this nonsense. Way up.
Join us again tomorrow for another truth-filled message on WBCQ at 9330 kHz on the 31 meter band. World's Last Chance Radio, preparing a people for the Saviour's soon return.
Get ready, he's coming. I'm listening to the sound quality now. It's pretty good. Well, we can wait a couple minutes and listen to the station ID and stuff like that on here. Well, okay, so it turns out the band that's the weakest is the only one that picks up a clear station. Which is kind of crazy, but it's only because the station is stupidly powerful at my place. So it's working, but it's just really weak still. I don't know if I can resolve that or not. Rest of the bands are all working, but there's nothing there to hear right now. I'll have to come in this evening and give it another try in the evening. See how well it's doing. Those stations were so weak, they're barely driving the detector, so they're quite distorted. The one that was up here.
Violent crime, political unrest, financial instability. Everything points to an impending crisis. A crisis like no other. Tune in to World's Last Chance Radio to learn how you can spiritually prepare for what lies ahead. WLC Radio, preparing a people for the Saviour's imminent return.
Welcome to WLC Radio. I'm your host, Miles Roby, and joining me is Dave Wright. Hello. Now, I would like to thank each one listening for tuning in and for making us a part of your day. Now, today we're going to talk about a very solemn warning contained in Scripture. It's very serious, and yet most people don't take it seriously. And what I mean...
I'm afraid I'm one of those people. Okay, well... So, strong station gives us a chance to hear how well the radio works. Radio's working really well. I think I may be right at the end of the road here, but there are some more things to do. There's Magic Eye to take care of. There's setting these band lights so they shine properly on the glass. That's actually a process we got to go through. And anything else I can think of. There's still a couple of capacitors to change that I've ignored because they are not critical. They're over here in the audio circuits. Yeah, I think we're getting right near the end game here. So thanks a lot for watching, and tomorrow maybe what I'll do is I'll focus on the Magic Eye. We'll get through that process, and I think that's pretty straightforward. I'm hoping you just plug in a new Magic Eye and bingo, here we are. Okay, well, thanks a lot for watching, and we'll see you tomorrow.